Today on TQA Weekly, I talk about wireless LAN channels, the signal widths of wireless G and N, interference, and how to pick a better channel that is not susceptible to defaults of other routers. This is TQA Weekly, where I answer your everyday technology problems and issues with solutions and answers to your everyday technology problems. So my name is Steve Smith, aka Z-Axis, the host of this show, and if ever you have any technology questions, problems, comments, suggestions, and or stories, you can always email me at ask@tqaweekly.com or head over to my website, tqaweekly.com. Today I'm going to be answering the question of what is a wireless channel, what is the signal width, what does that have to do anything with interference, and which channels are best for our network in order to benefit the most out of our experience and reduce the most possible amount interference from other networks. So we're going to use a few different ways of determining which channels you should pick. So first of all, the show notes for this episode are going to be at tqaweekly.com/SE3EP22. And we're going to start off with channels. So WLAN channels or wireless LAN channels. So for people around the world, there are 14 channels. Channel 14 is 11B only in Japan. Besides Japan, there is no other consumer market that can access channel 14 without a very specific license. Most of the world has access to 1 through 13, but for the benefit of everybody on the planet, especially those in North America where a lot of the people listen to my show, we only use channel 1 through 11. Tyranny of the default defines channel 6 as being the most common default channel since it sits in dead center of the actual suggested channels in North America by the telecom. So channels 1, 6, and 11 are the most commonly suggested channels for wireless by telecoms around here. In other parts of the world, it's 1, 5, 9, and 13. Since we can presume channel 6 is going to be the most common channel selected, we're just going to presume that's what people are using, since most people don't bother to turn off auto or change channel in their router. So we know that channels 1 through 13 are separated by 5 megahertz of space in between each other. So channel 1 being 2412, channel 2 being 2417, channel 3 being 2422. We should also understand that wireless G and N have access to a 20 megahertz signal. Wireless N also has the option of 40 megahertz signal, which we'll get to after. So if we consider the 20 megahertz signal being able to connect to channel 6 by default, we should also understand that this 20 megahertz signal actually affects channels 4, 5, 7, and 8, as well as being connected on channel 6, meaning that anybody connected to a channel that also shares interference in those channels will suffer interference from those channels, which means that if we were to select a different channel, it would have to be, if we only had access to 11 channels, 1 or 11, which is why the telecoms tell us these are the 2 best other channels than 6 to connect to. When you're connected to channel 1 using a 20 megahertz beam, you're going to actually have a range of 2402 to 2422 megahertz, which is outside of the range of channel 6. If you're connecting to channel 11, you're going to have access to 2452 or 2472 in your range for your 20 megahertz beam, which is also outside of 6. Remember, channel 6 is the default, which means if you were to connect to that, you would have a lot more interference by default. We don't actually know if the people changed from that channel, but we're just going to presume that they have. Now, wireless N's a little different. Since we have to stay within the 2.4 gigahertz spectrum, because that's the only space we have that is unlicensed, the best way to keep your 40 megahertz width of your signal is to be in channel 3, or channel 11 if we follow the 11 channel rule used by North America. Unfortunately, being in channel 3 means that we are suffering from interference directly from channel 6, whereas being in channel 11, we suffer less interference since we connect to channel 7 through interference, but never actually overlap channel 6. So if we had to use 2.4 gigahertz, choosing channel 11 for a 40 megahertz signal is a lot better than being in channel 3. So if you had a 20 megahertz wide signal in 2.4 gigahertz for your wireless G or N, channel 1 or 11, instead of using channel 6, which is the default. If you had to use 40 megahertz across, and because you're only using wireless N and couldn't for some reason connect to a 5 gigahertz antenna, channel 11 would be better than using channel 3 since the overlap is a lot less than channel 3 would have as an impact from people using channel 6 on the router. This is an option you can change in your router's administration under the settings. So if you want to play with those settings, go ahead. Changing the channel does not mean you have to change the password. It's just changing the channel. Now, if you have wireless N devices, have a higher end router with 2 different sets of antennas inside, like mine. So if you had something like a DI-R655, you have 2 actual antennas that you can use. Something else you can actually do is actually run a 5 gigahertz antenna inside for the primary antenna, connect your wireless N devices to that, and select either channel 1 or 11 for the secondary antenna or the guest network and run that at either channel 1 or 11. That would actually make your network run better with less interference. If for some reason you didn't have a second antenna inside your router, you can daisy chain, which means connect one router into the other, have one set to 5 gigahertz and the other one set to 2.4 gigahertz. Again, the 2.4 gigahertz stay outside, well outside the default of channel 6, so 1 or 11, as opposed to being directly into the default, which would actually slow down your internet experience. Otherwise, if you don't have any other way of dealing with this, or it's not based on a channel, consider some other possible issues for interference around your house, most notably things like Bluetooth, your microwave, the proximity of cordless phones and microwaves to your routers. If they're anywhere too close, they will interfere with your router. So make sure your router is nowhere near a cordless phone or a microwave, or as far away as possible from Bluetooth, since they do share the same spectrum. Besides that, next week I'll be getting into the topic of 32-bit environments, operating systems, and why they can't actually access all of 4 gigs or more of RAM. So I'll explain how that works. It's more math than hardware. So if you want to understand why you can't install more than 4 gigs in your Windows XP solution or any other 32-bit environment, I'll explain why that is. And besides that, remember to like this episode if you're interested in today's topic, share if you think someone else can benefit from this topic, and subscribe if you wish to learn more. For more information on this episode and other ways of subscribing to my show, because I'm not just on YouTube, I'm also on blip.tv, on Vimeo, on Miro Community, on iTunes, Feedburner, and a whole bunch of other places. So you're not just stuck on YouTube watching this show, if you're on YouTube, of course. You can always head over to tqaweekly.com, where you can also get our Android application, access the mobile website, submit your questions, comments, suggestions, and our stories. And now you can even submit your own technology articles if you are just starting out and want to get a name out for yourself. Remember, original content and sources for anyone submitting their own technology articles. Have a great day, stay safe and online, and goodbye.